Hello everybody and welcome to Assignment W. We're going to talk about the first page of Assignment W on page 245, and we have a focus on perpendicular bisectors and angle bisectors on these triangles. We're to find the value of each variable. So for number 1, we say that it shows us that DE is the perpendicular bisector of AC. That means that this side is congruent to this side, equal halves of the perpendicular bisector. So all we need to do is set the two expressions equal to each other. 6x minus 2 equals 7x minus 9. I'm going to subtract 6x from both sides to get x. I'm going to add 9 to both sides to get 7. And as simple as that, x is 7. For number 2, we have two variables to find. We have to find x and y. They're telling us that triangle CDF is equilateral, so that means each angle of the triangle is 60 degrees. This 6x right here, angle measure, is equal to 60 degrees. X equals 10. And then we have DE is a bisector, and that means the 8y is equal to the 10y minus 4, so we will set those equal. I will subtract 8y from both sides to get 2y. I'll add 4 to both sides to get 4. I'll divide both sides by 2 to get 2. So for number 2, x is 10 and y is 2. Number 3, we have an angle bisector. It's going to cut angle CDE in half, two equal halves, 4x plus 30 and 8x. 4x plus 30, we will set that equal to 8x. And we can solve for x this way. We'll take away 4x from both sides, and that'll make this 4x. And then I have 30 here. And then I'll divide both sides by 4. 30 divided by 4 is 7.5, or 7.5. Okay, and we've got two questions here to answer. For what kind of triangles can perpendicular bisector of a side also be an angle bisector of the angle opposite the side? So 4 is asking for a situation where the perpendicular bisector will double as an angle bisector, and that can only happen on a couple of triangles. Equilateral triangles, try to draw a sketch here, because all the angles and all the sides are equal. If I were to do a perpendicular bisector to it, it would cut the angle in half and also cut each side, the side opposite, in equal sections too. So equilateral triangles for sure. But also this could happen again. We just need this happen one time. So not only for equilateral, but also isosceles. Isosceles triangle, you have the same scenario where this side is equal to this side. And if I'm going to make an angle bisector from the vertex angle and drop it straight down, I would have a 90-degree angle down here. The angles would be cut in half, and my two sides down here would also be congruent. So this also works for isosceles triangles. Alright, last question. What kind of triangle do the perpendicular bisectors intersect at a point outside of the triangle? Okay, well, that would only happen on an obtuse triangle. Triangle similar to this, and then I make perpendicular bisectors for each of those sides. I'll try to approximate what that would look like. Coming off here, perpendicular. Coming off of here, perpendicular. And then coming off of this side, perpendicular. Now, notice how the intersection, I have to extend this out, it would be intersecting outside. So that would happen only on obtuse triangles. There you go.